It's recording. Here we go. So exercise 3FG and H1, I'm combining it together, and why I kind of paused last week and not continue on it was because I needed you to know how to read transformations. So 3D and E, I assume you had some time to do it, and if you haven't, well then you're going to just have to keep up with the pace I'm going to go. So 3FGH today. Next lesson, I'll give you a bit more of a breather. We'll do I, which is notations, and then you have your session, plus I'll give you a quiz along the way as well. And then Friday, we'll start chapter 4, which we'll just do 4A. It gives you a bit of a breather as well. Okay, but really, chapter 3, the key part was D and E. So assuming you've done D and E, I'm just going to pick an example. Let's do, you don't have to copy this one down because it will be very similar to all these other ones here. Okay, so if you haven't filled these spaces in, then you can copy the question I'm about to just write here. All right, so C, I'm going to just pick it from your textbook. Question C, you've got y is equal to 2 over x minus 1 squared plus 1. Really all they want you to be able to do from 3F, G, and H is just the opposite of that. F and G is just you sketching. I'm going to pause the video. All right, here we go. So they want you to be able to sketch. Now, to sketch an equation, you needed to know the graphs from last year. So the equations that you would have got would have been, can you sketch a 1 on x function? Can you sketch a truncus function? Can you sketch a square root function? Can you sketch a circle function? Can you sketch a, I guess, any polynomial function? So x to the power of n. And that kind of gives you the variety that you need. You got sine, cos, tan as well, right? In exercise 3F, they've got a variety there, but it's mainly rectangular hyperbole, square root, and a truncus there. Your job is to be able to read the transformation from this. And if you can't yet, then you can memorize the way I'm about to teach it to you, but it's not ideal. So let's do a few readings to start off with. Anything that you add or subtract, that is a translation to do with the y transformations. Okay, anything to do with x is always where the x is. Okay, so that's all the x transformations. Every other number that you see is a y transformation. So I'm going to highlight it in blue. Y transformation, y transformation. So what do you think the plus 1 could mean? Let's go with Alex. What do you think the plus 1 might mean? 1 unit up. Very good. So this is 1 up, or up by 1. What do you think the 2 might mean? Can I please have, let's go with Neil. 2 what?
Dilation factor 2.
Good. So dilation factor 2. And because it's affecting the y, so remember the y's, move your hands up and down. That's moving away from the x. So dilation factor 2 from x. And then now we look at any transformations to do with the x. And remember, this is a truncus function. So usually you do x squared. There's a change to the x. So that's the transformation for the x. So let's have a look at the x transformation now. What do you think the x minus 1 does? Let's go with Albert.
It moves it 1 unit to the right.
Perfect. 1 unit to the right. There is no dilation for the x, and there is no reflection at the moment. So as long as you know the basic graph of a truncus function, which we know it is usually like this, 2 asymptotes, vertical and horizontal. What we know is it's going to move right by 1, up by 1. So your asymptote now goes across by 1. You must label the asymptote, so you should write x equals to 1. And it goes up by 1, so that means you've got a horizontal asymptote now at y equals 1. And it's a truncus function, so everything's the same. There is a dilation, but they can't tell. When you draw it, they can't tell if it's a dilation or not. Your textbooks would choose a random coordinate just to show that it is a dilation of factor 2. So you can pick, for example, pick the number x equals 2. Pick a point. So if x equals 2, sub it in. So 2 minus 1 is 1. 1 squared is 1. 2 divided by 1 is 2. And then 2 plus 1 is 3. So you can write 2, 3 just to show that that will give you a dilation of factor 2. Yeah? And that, right there, is your transformation. So I've got the dilation, I've got the translations, no reflections. If there was a reflection, we would then sketch it flipped other way. Yeah.
There was like a side question asking us like to sketch that transformation. What points would you have?
what points do we have to write? Usually, when they ask you to sketch, one of the things that you must have is axis-intercepts. Okay, so I clearly would have lost a mark for not figuring out the y-intercept. In this case, there's no x-intercept. The other one is key features. So in this case, asymptotes. So this is the second mark. Your third mark is your shape. So whether it's in the correct translation or transformation, whether it's reflected up or down, that's where your 3 marks generally is. So it's mark 1, axis-intercepts. Mark 2, key features. So different graphs have key features. Yeah, for example, like cubics. Yep. And then the last one is the shape. So for example, if it's a linear graph and then you did it by hand and it was like that, they'll take a mark off and that will fall under shape. So you would have to use a ruler to make sure that anything that is linear, it better look linear. Okay, so find a way to draw a linear graph. And same thing with any asymptotes. When you draw an asymptote, obviously I'm not careful there, but in an exam, they would check if your graph goes like this and it goes back up. If there's a tail that goes up, they'll take a mark off. So that bit there, that falls under shape. Okay, so they want to see that when you're drawing it, it actually comes close to the asymptote and it's implying that it will forever get smaller and smaller. Okay, so those are your 3 key things that you should look for no matter every time you're sketching. No matter which function you get, those are the 3 key things that they'll look for. Okay, so usually it's the 3 marker. In the exam, now that I've seen for these type of questions, if they get you to sketch as exam 1, they'll give you a grid. So if they give you a grid, the added layer is that you need to make sure that the points make sense now. So that means your dilation does matter. Okay, whereas when I'm drawing that, there's no axes, no grids. Doesn't matter. Previous years used to not, but then nowadays I'm seeing more grids. So that means they'll keep the domain short and there's certain key features they're looking for. So it might be the turning point. It might be that it has to cross through 1, 1. It might have to be symmetrical, something like that. So the grid means that you have to draw it to scale. Yeah. So that makes it just a bit harder and you guys got to be more careful. But when you're doing your exercises, don't draw the grid. Just draw the key features. But if you get a question with a grid, make sure to draw it according to scale. Okay. All right, so that's essentially what you're doing in these exercises here, or exercise 3F. It's about identifying the transformation. So maybe another tricky one is B. Let's just read the transformation for B. Give me one transformation that you can see. Let's go with Noah. What do you see? Good. This one's up. Up 4. Give me one transformation that you can see. Let's go with Ella. Oh, no, just any transformation.
It's translated 3 units right.
Good. You were right the first time. It was 3 units right. Give me another one, Dante. And one more. Let's go with Mia. Good. This was the one that I was saying that's a bit trickier because compare the other 6, there was a hidden reflection. In exam, that's what they often do. Okay, so these ones here didn't have that negative on the x. It's always the x transformation that they'll try to get you. So they'll put a 2 there, they'll put a 4 or a quarter, and you are meant to know it's the reverse. So here is a reflection that students tend to forget. It's a reflection to do with your x's. So if the x's move, it's moving over the y, so hence reflection in y-axis. And what kind of graph do you have? Rectangular hyperbole. So as long as you sketch rectangular hyperbole, follow the transformations, that's your new graph. Okay, so that's what they're trying to get you to do. But the ability to read that the way that you guys have, that's what you want to be able to do from 3F to 3G. Cool? All right, now open up your sheet to 3G. Now we're going to start on from the notes for 3G. It's the same thing. The only difference is it's now power functions. So it's x to the power of n. Now, there are a couple of things I want you to see with x to the power of n. So I've actually put in the screenshot of some Desmos graphs. Exercise 3G, x to the power of n when it's odd, x to the power of n when it's even, integers. Okay, integers meaning whole numbers. So when you have whole numbers like x cubed, what I actually typed into the Desmos was this was actually x to the power of 5, and then I went to x to the power of 9. Okay. Versus on this other side, it was x to the power of 4 Then I had x to the power of, this is x squared, by the way, 4. Then I went to 6, and then went to 8. Okay? I want you to tell me, what do you notice about the two graphs? So when it's odd versus when it's even, what's a key property? What's a key property? Because that's what you're going to fill in. The graphs are, when it's odd, very good. Symmetrical when it's even. And then asymmetrical. Ooh, let's go with my pen. Oops. Asymmetrical when it's odd. Hence you get this, like, as you go further left, it goes further down. You go further right, it goes further up. It's a very simple idea, but it is helpful when you're identifying what kind of, how the shape's going to go up or down. So later on, when I give you an example, I'll show you some examples where I change the axis or factorize linear factors. You'll see how you can predict whether it goes up on the right or left. Okay, I'll give you an example soon. So in this case, in exercise 3G, they will then say, okay, well, if it's x to the power of n, if I put in all the transformations, this is what they call, like, what you're used to calling turning point form. But essentially, it's just that same graph with all the transformations you got. So here, the general transformation, this is up, down. This will tell you left or right. The power of n is just the shape of the graph. And then A tells you a dilation. That A is the dilation from the, that's affecting your y value. So from the x-axis, or whatever number you put there, that's affecting your y's. Okay? So in your exercise, what you'll get is a bunch of different versions of this graph, and your job is to sketch it. Now, one of the key things I want you to note here is stationary point, which is what we call turning point as well. This is at h. Okay, only because that's a negative h here. If that was a plus h, that'd be a minus h there. Okay, because remember the x transformation is the opposite, the left to right. It moves opposite, so if it's minus h, it moves to the right. If it's plus h, it moves to the left. Yeah? This one is still the same. This is also h. Okay? But I want you now to look a bit closer about the graph. There's another feature to note. What happens when I go from cubed to 5 to 7 to 9 to 11 to 99? What's happening to the graph? What would you describe it as being? What's happening? Okay, so we can see that this point, it's getting steeper. So this is your x cubed, x5, x9. So eventually what you're going to probably expect is going to look something like this, right? But the change is very key. So the reason why I put this y equals x line in there, and then I labeled the points for you to see, why do you think the change happens right there? So on the x-axis, from -1 to 1, there's something special about it. So what's happening between -1 and 1? What's happening as I increase the power, odd powers, going from 5, 9 to 99, and eventually it kind of looks like this. What's happening between -1 and 1?
The decimals, so when they get higher the power, the smaller the number becomes.
Yes, that's right. So it actually gets flatter. But then, as soon as you pass 1, it skyrockets up. Okay, so when you pass 1, so 2 cubed versus 2 to the power of 5, 2 to the power of 9, or 2 to the power of 99 shoots up really high. But in a fraction form, say half cubed versus half to the power of 9, this is the same thing as saying 1 on 2 cubed, which is 1 on 8. But then if you think about it, 1 on 2 to the power of 9, the larger the denominator, the smaller the overall value is going to be. Because 1 divided by a very large number, if you had $1 and you had to share it to 2 million people, everyone gets very little. But if you only had $1 and you shared between 8 people, each person's going to get more than the million people that you have, right? So that's why anywhere between 0 and 1, it's fractional. The numbers get smaller and smaller. That's why for the x cubed, it's higher. The purple line is much higher. And as you increase it, it gets flatter and flatter and flatter. So theoretically, if I increase it to 99, you should kind of look at, it looks like a square box kind of thing. Does that make sense? Okay, so that's a property to note because they sometimes use that idea between the -1 and 1. Just note that when you do it to the power of fractions, it actually gets really small, okay, rather than getting really large. And then same concept for even powers. Same idea. That's an x squared graph. When I increase 2, 4, 6, 8, if I went to 100, which is an even power, you start to see the same thing. Between 0 and 1, it's getting flatter and flatter. So what you expect is if I gave you x to the power of 100, it's getting closer to looking more like a boxy shape. Okay, and that box only happens between -1 and 1 because that's where it's fractional. Okay? So far, so good? That's the only properties I thought I'd describe. But other than that, what you'll be doing is something like this. Here we go. Let's try to sketch this. So this is from your exercise 3G, and I just chose question 11 for the sake of it. Here's your question 11. F of x equals to 2 times x minus 1 to the power of 5. So I know it's an odd power. So what I should be thinking about is asymmetrical. And then I now read the transformations. So asymmetrical, I know it's got, what do we have? Let's name a couple of transformations you can see now. So name me one transformation you can see. Let's go with, when I pick Xavier. What can you see? What transformation can you see in this equation? Down by 2. Very good. We've got down by 2, which is over here. That's down by 2. Give me another one. Let's go with Serena. To the right by 1. Very good. This is right by 1. Right here. That's right by 1. And then what does the 2 do? Let's go with Joe. It is from x because you're affecting the y coordinates. So you're doubling it in that direction. So it's from the x, but it's a factor, not half. It's 2. The only time it's half, it's when it deals with the x. So if I put the 2 in here, had it been 2x minus 1 to the power 5, then what you said is correct. Oh, well, then it will be from y. Yeah. Okay. So dilation of factor 2 from the x. Obviously, this question is not asking for us to describe the sequence of transformation, so you wouldn't have been penalized at that point. When you sketch it, dilation is really hard for them to see, okay, so they can't tell. You just draw the shape, yeah, unless they give you a grid. So here, how do we draw it? Well, we know it's to the right by 1, so normally we can expect it to look something like this. To the right by 1, down by 2, so to the right by 1, down by 2, somewhere here. That means my shape, again, there's no reflection, so the shape should still be as it is. And when I draw it, something like that. If you have a grid, you're going to make sure it's to scale. Because I don't have a grid, I'm just going to draw it as it is. And what am I missing? If I were to get my 3 marks, what am I missing? Good. And? Very good. And so this goes back to y-intercept, let x equal to 0, and then x-intercept, let x equal to 0. I mean y equal to 0, and then you solve. Okay, and then just make sure to label those key features, x-intercept, y-intercept. Y-intercept's the easiest. Let 0, so -1 to the power 5 is -1, times 2 is still -2, -2, take away 2, -4, so that must be 0, -4. Okay, and if you want to show the dilation, just pick a number. Doesn't matter which point. Pick a number, so say 3 as an example, sub it in, and then write the coordinates. That will show a dilation, if you want to. I'm pretty sure the examiners won't ask for that, and the reason why is because they won't have time to check what number you've chosen. Some student could choose 100, some student might choose a half, so they're not going to check that. So that's why usually they give you a grid, and you have to draw it to scale. That's why. Then everyone does the same thing. Okay? If it is a 0 gradient, yes, which we haven't tested whether it is, but usually, yeah. If you do the derivative and then you find let equal 0, but we haven't gone to that point. Usually, if there is an inflection point, you must. But if there isn't, oh, it did too. Well, then yes, we have to do the derivative. But we haven't done derivatives, have we? Chapter 3. Okay. All right, yeah. Well, in this case, I think they were just trying to say that point. Or maybe I typed that. You said that? All right, well then it must assume that you know how to do the derivatives at this point. So that must mean that is a 0 gradient. So in that case, that would be 1, -2. All right, team. Let's go to the next question. Let's find one that has something a bit different. You can probably do 7F now. That's pretty easy. Oh, let's do 3G. Question 8. Let's have a look at this one. So now that you can read the transformation equation, what they'll also get you to do in 3G is to find unknowns given certain points. Let's start with this one. They tell you already the template. You've got thanks team. You've got something to the power of 4, so clearly it's an even powered graph. We don't know what K is, H and A, but it tells you it has a turning point at -2, 3 and passes through the point 0, -6. What's a big hint already? Ian, what can you see? What's the big hint that they've given us that we can start off? Turning point is -2, 3, and it passes through the point 0, -6. But out of those 2 points, one is more important than the other at the moment. Turning point. Why is the turning point currently telling us a lot? Let's go with Pat. Very good. And just be careful because it's written as -h there. And we know that we want a -2. So the number there, when you sub it in, make sure to keep that negative there. So hence it becomes y equals a bracket to the power 4. If you want it to move to the left, this should end up being a +2. That's your x. And then your plus k must be 3. So now I'm missing the dilation. I've got my horizontal translation, I've got my vertical translation, and that's where the second point that they've given you, 0, -6, sub 0, -6. That means x is 0, y is -6. And we'll get -6 equals a bracket 0 plus 2 to the power of 4 plus 3. Let's work that out. 2 to the power of 4. What's 2 to the power of 4? Let's go with Emily. What's 2 to the power of 4 equal to? 16 is correct. So we get 16a plus 3 equals -6. Take away 3 on both sides gives you -9 equals 16a. Therefore, a must equal to what? Can I please have Ryan? -9 on 16. Pretty straightforward. So 3F, we're sketching your rectangular hyperboles, your square root functions, your truncus functions. 3G, sketching polynomials, so with integers, integer powers. So you have odd and even, looking at the properties and solving. So far, so good. And then when you go to 3H, it's just working backwards. So instead of us giving you the equation, we're going to give you a graph, and your job is to use the graph to look at the properties and then identify what the equation should be. Okay, so it's all within the one skill. So you've got sketching, using transformations, and then you've got determine the equation from the graph backwards. Cool? Let's do an example. Flip to the next one. You should have exercise 3H now. Let's have a look at 3H. 3H should look something like this. Let's see. Normally, when you get in the exam, they don't give you this. But they will tell you it's a rectangular hyperbole. And then you have to figure out the equation. Okay? So, your textbooks give you a sort of a guidance. They actually give you the equation. So they give you, and clearly it's a rectangular hyperbole. Here's your graph. Got x equals 1 as an asymptote, y equals 4 as an asymptote, and it crosses through the point 0, 1 as your y-axis intercept. Your job is to figure out what A, B, and C is, meaning what's the equation. What can I already determine for the equation? Let's go with Tara. What can we see already? It goes up by 4, so which letter does that represent? C, very good. So we can see the asymptote, which originally was on y equals 0, has gone up to y equals 4. So we know C is responsible for up by 4. So hence, C must be plus 4. What else can we also see at the moment? Let's go with, who haven't I picked yet? I haven't picked Samuel. Samuel, what else can we tell? So we got C. We know that B is 1. Why is B 1? Okay, so we want to move. We know this is going to move to the right by 1. What do we have to be careful when you're moving anything to do with the x transformation again? It's the opposite. So underneath that, if you wrote +1, it will move it to the left. Okay, so this one actually should have been a -1. So just be careful. Anything to do with x transformation, x minus 1. So b must be -1. C must be +4. And then, how do I find A? Very good. Just like before, sub in any other piece of information we got. We got 0, 1. Sub 0, 1 in to find A. So I get 1 is equal to A on x minus 1 plus 4. And, oh, sorry, it should be 0 there. And let's solve. That becomes -A plus 4 is equal to 1. Minus 4 on both sides, so that gives you -3 equals -A. Therefore, A must equal to +3. So we now have dilation of factor 3 from the x-axis. Okay, so that's to do with the y's. How does that feel so far? So even though I'm going through 3 exercises, you can see it's only really 2 skills. One is reading the transformation from the equation to sketch. And then the other one is I give you a sketch graph and you got to work backwards to figure out the transformation. Okay. Let's do one more example and then I'll give you your time. Let's have a look at this last example here. Your last example, the points -2, 0 and -3, 1 lie on a curve with equation, which that's a square root function there. So you've got a square root function. Find the values of A and B. Woo! How do we do this? So we don't have a graph. That's a square root function. What are you going to do to begin with? Alex, got a tip? Yeah, that's right. Likely it's going to be a simultaneous equation because you've got 2 pieces of information, which is an x and y coordinate. So you get these. Doesn't tell you anything about A and B, but because they gave you 2 points, likely you're going to get 2 equations. So here, what you're going to get is sub -2, 0 in. You will get the equation 0 is equal to A square root of -2 plus 3 plus B. Let's simplify that. That becomes 0 equals to A root of 1 plus B. And that becomes A plus B is equal to 0. Versus, if I subbed -3, 1 in, then what I'm going to get here is I'm going to get 1 is equal to A square root of -3 plus 3 plus B. A times 0 plus B. Oh, this works out to be easier, actually. I was actually hoping there was a simultaneous equation. What? Wasn't as hard as I thought, I guess. So A times 0 is 0, and 0 plus B, well, that just tells us B must be 1. But if B is 1, then 0 equals A plus 1. Therefore, A must equal to -1. Usually in the exam, it would be a simultaneous equation, usually. But I guess that was happens to be an easier one that I chose by accident. Okay? So far, so good. That's 3F, 3G, 3H. Take your time. It comes from 3D and 3E. Get your 3D E right. FGH will be fine. Next session is I, and you'll have most of the session to yourself with the quiz as well. Okay? It'll be chapter 1, 2 quiz again before next week we'll do transformations quiz. I usually do it on the Wednesday. Is it Wednesday that I have you, or is it Thursday? Thursday, second session. All right, I'll stop the video here, and if there are any questions on the previous exercise, let me